In this lecture, I will explain the database system concept and architecture. The architecture of DBMS package has evolved from the early monolithic system, where the whole DBMS software package was one tightly integrated system, to the modern DBMS package that are modular in design with a client-server system architecture. In the earlier era, whole DBMS software package was one tightly integrated system. My the whole DBMS system was only one integrated system, and there was an organization that control whole DBMS system, and he handles every operation, storage, security, and user access. All those operations was handled by only one system in the earlier era, but in the modern DBMS package that are modular in design. This design of this database management system is modular. Modular means there is something big problem and divide into in small. That is called modular. We divide our system in small module. That one module handle some problem, some solve some problem. Another module solve some another problem. Like we design our database in module by module. This module by module design share our big task in many people, and many people can work in module, and they can and after the designing every module they will integrate the module, and our whole DBMS system will start working. And with a client server system architecture, and we use the concept of client server system architecture in the modular design, where a large centralized mainframe computer are being replaced by hundreds of distributed workstation. In the earlier there was only one integrated system, but after the some evaluation, our large centralized mainframe computer replaced by hundreds of distributed workstation. There are hundreds of distributed workstation. They perform their service, and they provide the service and work for a single system, and processing is done by the all hundreds of system, and the our task is divided and distributed to different system, and different system process our query, and the personal computer connected via communication network to various type of server machine: web server, database server, file server, application server, and so on. The client, what is the client? The client module handle user interaction and provide the user friendly interface such as form or menu based GUI, graphical user interface. The client module that our system have different module, but the client module this handle the interaction, user interaction, and provide a user friendly interface. This module of my system provides a user friendly interface and graphical user interface. This module, and another module, the other kind of module called server module. This module of system typically handle the data storage, access, search, and other function. First module is client module. This module provides a user-friendly interface such as form or menu-based GUI, graphical user interface, and another module is server module that handles storage, access, search, and other function. There are two modules: client module and server module. And next is data models, schemas, and instances. What is data model? Database provides some level of data abstraction. Data abstraction generally refer to the separation of details of data, organization, and storage, and the highlighting the essential feature for the improved understanding of data. Data abstraction means hiding suppression of details of data. We don't show the details of data and how the data is stored in the storage, and it highlights only the essential feature for an important understanding of data. We don't show everything about the data because there are many operations, many functions that are used for storing, designing, and many more operation. But we highlight only the essential feature of an improved understanding of the data. One of the main characteristics of database approach to support data abstraction so the different user can perceive the data at their preferred level of detail. Means different level of user like there is database administrator and designer, engineer, maintenance engineer, and end user. There are different type of user, but DBMS provide different view and different of database, and different people can access the data at their level. How much data they want, what are the level. A data model. What is data model? A data model is a collection of concepts that can be used to describe the structure of database, provides the necessary means to achieve this abstraction. What is the data model? Data model is concept that can be used to describe the structure of database. This data model will describe the structure of database, and it will provide the necessary achieve the abstraction. This data model will provide the data abstraction. Abstraction means different level of view, different level of view data, at which level who can access the data. If I have a database of the any university, shall any student can see the data of any professor. Eh, every actor has different level of the access of the data. That is this facility is provided by data models. This data model is collection of concept that can be describe the structure of database. Okay, that's why data models is very important. A category of data model. There are some categories given below of data models. How the data model will help in providing the necessary means of abstraction. We will learn the category of these data models. High level or conceptual data models. First is high level or conceptual data model provides the concept that are close to the way many users perceive data, where low level or physical data model provide the concept that describe the details of how the data is stored on computer storage media, typically magnetic disk. Two level of data models, two type of data models. High level or conceptual data models provide concept many user perceive the data. Many user, this is high level of data, like the user that access the data, that that is designed by the high level conceptual data models. But the at the low level or physical data model provide a concept that describe how the data will be stored in the computer or disk or magnetic disk. Okay, this is provided by the low level model. Two type of model. Conceptual data models uses concepts such as entity, attribute, and relationship. This conceptual data model uses entity. Entity means something that exists in real world and it has some properties and attributes. Called entity. And this data conceptual data model uses entity, attribute, and relation for the designing the high level of data models or conceptual models, for providing the data abstraction, means different view of data. An entity represents real world object or concept such as an employee or project from mini world that is described in the database. what is the entity? Entity is real world or object or concept like an employee or project from the mini world that is described in database is called entity. Attribute. An attribute represents some property of interest that feature describe an entity, such as employee's name or salary. Attributes of any entity has a attribute like name, roll number, location, mobile number, email, grade, etc. These are the attribute of any entity. Entity, what is the entity? Real world object or concept. And relation, what is the relation? A relation among these two or more entity represent an association among the entity. For example, a works on relation between employee and project. Relation represent any association, how one entity is associated to the other. What is the relation between the any project and employee? How the employee is related to project, how any student is related to any college, how any professor is related to any college, what is the relation of any professor with the college, and what is the relation of the any student with college. This is called the relation between the entity, and that represent the association among the entities. Entity relationship model, a popular high level conceptual data model. We will learn the entity relationship model that will represent the high level conceptual data model for designing of high level data models. Representational or implementation data models are the models used most frequently in traditional commercial DBMS. These include the widely used traditional data model as well as the so-called legacy data model, a network or hierarchical model that have been used in past. Part 2 is devoted to the relational data model and its constant operation and language. The SQL standard for the relational data is described. Okay, the SQL standard for the my standard is this SQL language is designed by the relational database model. Schemas, instances, and database state. The description of database is called the database schema, which is specified during the database design and is not expected to change frequently. The schema means design of any database that describe the database, how the data is defined, what are the different attribute. If, let's suppose there is relational table. In the relation table of employee, what will be the attribute? Name, employee, location, phone number, email address. And what will be the attribute that are already defined in the database schema, and it is not change frequently. Once you have designed your schema, it is not change frequently. After it change in long time, you can change frequently, but it's generally it change after long time. If you want to add some more attribute of any employee, let's you want to add salary attribute of any employee, then you can add the salary attribute also, and you can remove some attribute. And this is not changed frequently. The schema database description of database, a schema diagram display only some aspect of a schema, such as name of record, type or and data item, and some type of constraint. A schema diagram that will be used for our designing our database, relational database diagram. It will represent the name of record type, data items, some types of constraint means what will be the constraint of these attributes that and that are using in the relational data model. What will be the constraint will be applied when you are storing the database. Three schema architecture and data implementation independence. Schema means design, how the database is designed. Three or four important characteristics of database approach. First is the use of a catalog to store the database description schema so as to make it self-describing. First property of database approach is we store the schema, means design of database, that is called database catalog. And this schema design self describes the database, how the database is described, how the database data is stored in the database, what are the relation, what are the different attributes, and what are the constraint. And your application program that is using the database first read the constraint and it will read the schema, and then he will use according to the constraint and schema. This is the first main characteristics of database approach. Second characteristics is insulation of program and data program operation independence. Second is the data program, my database is independent of any programming language. It doesn't matter which programming language you are using for accessing the database. It is independent of any programming language. Not depend. My database is not depend upon any programming language. This is the second property, main characteristics of database approach. That was not in file processing approach. File processing was approach was depend. Database was, my program was dependent upon the database, and database was designed for only some application, some programs. And third characteristic is support of multiple user view. Third main characteristics of database approach is it support multiple different people can see the database according to at the different level, different part of the, if the any person want to access only employee database and he want to access only the name of employee, employee id and salary, then he can see. And another person he want to see the name of employee and location of the employee, then he can see according to their use. They can use according to their necessity. It support the multiple user views. And in this section we specify an architecture of database system called the three schema architecture that was proposed to help achieve and visualize these characteristics. We will discuss the three schema architecture that will propose to help achieve this and visualize these characteristics. This will help to visualize these characteristics. These characteristics that I have discussed above, this will be achieved by the three schema architecture. What is three schema architecture? The goal of three schema architecture is to separate the user application from the physical database. Goal of three schema architecture is separate the database from design from user application from the physical database. How the database is stored in disk or physical storage is independent, is separate from the our database that is accessed by the user. User don't need to worry about the how the data will be stored in the disk or storage. He need to worry about the how the database is designed. Okay, three levels. Internal level has an internal schema which describes the physical storage structure of the database. Internal level schema architecture defines the how the data will be stored in the physical storage. conceptual level. The conceptual level has a conceptual schema which describes the structure of whole database for a community of user. The user that is using the database is designed by conceptual level schema. This conceptual level schema first gather the requirement of user, and it will design the schema. At this level, conceptual level, designer will design the database schema for the user. The conceptual schema, that is conceptual schema. The conceptual schema hides the details of physical storage structure and consent on the describing entities, data types, relationship, user operation, and constraints. This conceptual schema hides the physical storage structure, means it hides the details of data that is stored, how the data is stored in physical storage. It does not show the how the data will be stored in the physical storage. It will concerned about on the describing entities, data types. What will be the data types of data? If you are storing the data of name of any student or any employee, then what will be the data types? It will be string or any another thing. And the relationship between the entity, what will be the relationship between the two entities? And user operation, and how much what which type of operation user can perform, read, write, update, delete. These are handled by, designed by conceptual schema. And constraint, what will be the constraint, like what will the length of any, maximum length of any person's name, maximum digit in any phone number, constraints in any email id. These this is concerned on the conceptual level. External schema, external view or external level architecture. It includes the number of external schema or users view. It includes the user view, how the data will be, database will be visible to the user. Each external schema describes a part of database that a particular user group is interested in, and hide the rest of the database from the user group. This external schema describes only the part of database that a particular group of user is interested, not whole the database. This external schema only show the specific database that is any user group are interested. Like Facebook has a lots of data in his database, but he give us access only, we can access our photos, videos, and comments and chats. We cannot access the whole database of Facebook. DBMS architecture, the view of a three schema architecture. The major purpose of DBMS to provide user with an abstract view of data. Abstract view hide the implementation details, so the only the database, that conceptual view or user view of data. That is, the system hides the certain details how the data is stored and maintained. To simplify user interaction with the system, abstraction is applied through the several level of abstraction. We apply the different level of abstraction for simplicity of user interaction. The main objective of three level architecture is to enable the multiple user to access the same data with personalized view while storing and underlying data only once. The main objective of three level architecture is provide a multiple view of the same data. First is the external schema or physical level or physical level or internal level schema architecture. This is the lowest level of abstraction, describes how the data is stored, and it is low data structure or low level data structure are used. In the low level schema, we use some data structure like which data structure are used for storing our data in our disk and storage, and how to which data structure should I use for the efficient operation and efficient access. This is de- defined in the low physical internal level or physical level architecture. It has the physical schema which describes the physical storage, physical structure of database. Talk about the storage allocation, array tree, etc. Data compression and encryption. Storage and array tree, how the data will store means we can use the B tree and array tree for the storing the data in our database. And data compression, if you are storing any image, and we can use some compression algorithm for compressing our image then store in the database. And it is done in this level, physical level. And encryption, if you are storing some password of any person, then use some encryption algorithm for or hashing algorithm for storing the password in the database. The goal of this level is we must define the algorithm that allow efficient access of data. We define some algorithm that will efficiently search the data, fetch the data, read, write, all the operation. We define some algorithm in this level, physical level or internal level. We use the different algorithm for data compression and hashing algorithm for password hashing, and different data structure for storing the data, and different algorithm for searching algorithm, which type of algorithm are used for searching in data. Like this, all these are done in the physical level, all internal level of schema. And second is logical level or conceptual level. Conceptual schema describes the design of database at conceptual level. Describe what the data are stored in DB and what the relationship among those data. This this level conceptual schema describes the what will the relationship between the different entities, and the how the database is designed. User at logical level does not need to aware about the physical level structure. Okay. DBA database administrator who must decide what information to keep in DB use the logical level of abstraction. Goal, what is the goal of this logical level? Easy to use. This describes the design of the logical schema like ER diagram, and for the designing the relationship and between the different entities, and it is so that it's become easy to use. External level, highest level of abstraction, aim to simplify user instruction with the system by providing the different view to end user. At the end user, it provides a different view for the end user for simple user interaction. Each view schema describes the database part that particular user group is interested, and hide the remaining database from the user group. There are different group of user that is using the same database, but it does not show whole database to particular user. It will show the only the required database for the user, and the required database for another group of user. It supports a different view of data, and this is done in different view. This is done in the view level or external level of schema. At the external level, a database contains several schema that sometimes called as subschema. This database contains different type of schemas. The schema is used to describe the different view of the database. Subschema means different. We have the huge amount of data that is stored in the database, and this external level schema contains different sub schema for different group of people, and it provides a sub schema for different group of people. At, at view level, it also provides a security mechanism to prevent the user from accessing certain part of DB, and any user can access only certain part of database. It cannot access the another group of people's users database. It can access only authorized that is that is authority to him, not hold the database. You can see external level schema, conceptual level schema, internal level schema, and physical disk. How the data will store in the disk or storage. Instances and schema I have already discussed. Data models. Data model provide a way to describe the design of DB at logical level. Logical level or conceptual level, that was middle level. A data model provides how to design this logical level schema. That I have learned the conceptual schema. Underlying the structure of database is a data model, a collection of conceptual tools for describing the data relationship, data semantic, and consistency constraint. ER model, relational model, and object-oriented model. These are models are used to design our database at this logical level, in conceptual level. Our logical schema or logical conceptual schema is designed by the either ER model, relation model, object oriented model. We can use any one of the model for designing our conceptual schema. In the next lecture, I will discuss the ER model and double ER model and the relational model. And the second topic is database language. First is data definition language, DDL, to specify database schema. This language, data definition language, is specify the database schema, design of schema. This language is used for the designing of the database. And second type of language is data manipulation language, to express database queries and update. This language express the database queries and update. This language performs different queries in database and update operation in database. This is done by the update and queries operation is done by data manipulation language, DML. Practically both language features are present in single DB language, is SQL language. Both are both our language are present in the our SQL. MySQL provide both data manipulation and DML, both language. DDL, we specify in data definition language, we specify consistency constraint which must be checked every time database is updated. Consistency constraint must be checked before update in database when you are updating. DML, data manipulation language. Data manipulation means queries and update operation. You are doing queries and update operation with the help of data manipulation language. Manipulation language involves the retrieval of information stored in the database. It can perform the retrieval, insertion, deletion, and updation. Insertion means new information into database. Deletion of information from the database. Updating existing information stored in database. All these operation is done by the data manipulation language. Manipulation query means a part of DML manipulation language to specify a statement requesting to retrieval of information. Manipulation means retrieve, insert, delete, and update. Query means you are searching something. Retrieve, requesting of retrieval of information. Searching. How is data accessed from the application program? How my app will access the data? Like if you are using Instagram, Facebook, if you if you scroll a reels, then how this application program will access the video or photos from the database. Apps written in host language C++, Java, etc. interact with database. These programming languages will deal with interact with the database. Easy banking system module generating the parallel access database by executing the DML data manipulation language statement from the host language. API is provided to send DML or DDL statement to database and retrieve the result. There are different API present. They send the request to the server or to the database, and the database will fetch the information and it will provide to the application app, our application program. The database connectivity, Microsoft C, Java database connectivity, these are the API that are used to for the database access. Database administrator, I have already discussed about the database administrator and the different actors in the database. One of them is database administrator, a person who controls both the data and program that access those data. Functions of DBA: schema definition, storage structure and access module, schema and physical organization modification, authorization control, routine maintenance, periodic backup, security patch-up, and any update. DBMS application architecture. Second topic is DBMS application architecture. Database management system application architectures typically involve client machines where user interact with database remotely and server machine where the database system itself run. Client machine where the user interact with database remotely and server machine where the database system itself run, that is server machine. Overview of these two component. First is client machine. Client machine, these are the components or device used by the end user to access the database, like laptop, tablet, even the smartphone. These are the client machine that are used to access the database. And how these client machine will access the database? These client machine will access the database with the help of the application program, any app or website. Like user interact with the database through client application or interface, which can be web-based desktop application or mobile application. Yes, we can use any mobile app or desktop-based app or any website for accessing these database. That client machine typically run software that communicate with database. This client machine is my phone or laptop. This will run a software. This software means that any application, app or any website, my client machine will run any website or app, and this website or app will access the database server to perform the operations such as querying, updating, and managing. This software will perform querying operation like querying, updating, or managing. If you are using gallery app or photos, Google Photos, then my client machine is my mobile and application program is my app Google Photos, And if you add some new photo, then you will add the photo in your database with through the app, and this will be updated in your the database, that is your drive, Google Drive, that is provided by the Google, and it will updated and it will visible to you. Then client machine is my phone, and server machine is where the data is stored, that is stored by the server. What is the server machine? Server, these are the computers or the servers where the database management system is installed and runs. Server machine that runs the DBMS software, and then DBMS software will manage the database. Server machine are responsible for storing and managing the database itself. These server machines are responsible for storing and managing the database itself, like including handling data storage, retrieval, and processing. And if you add some photo, and that will add it to your drive, and who will add to your drive? The server machine. This will, this photo will go to the server, and the server machine will add to your this photo to your account. And depending upon the architecture, there are different type of server machines. There are different type of server machine. First type of server machine is database server. This is primary server responsible for managing the database system. It hosts the DBMS software and store the actual data. Database server machine actually store the data with the help of DBMS software. DBMS software that will handle the all the operation in the database, like read, write, update, query, all the operation handled by this DBMS software. And this database server actually store the database data. Applications server, in some architecture, they may be there may be separate application server responsible for hosting application logic and business rules. This The application server interact with the database server to perform the database operation on the behalf of client. In some architecture, they create some application server that will take the query or request of the user and perform the operation in the database according to the user query. If a user is saying show my photo, then this application server will fetch the user's account photo and show to the user. This is the application server. Web server, in the web based application, a web server may also be involved. It hosts the web application interface and may communicate with the application server and database server to serve dynamically content to the client. Web server dynamically communicate with the both application server and database server. He takes the query from the application program and perform the operation on the database. This is done by the web server. Server machines are typically most powerful in terms of processing power, memory, storage capacity compared to client machine, because they have to perform the mm, a lots of millions of operation at a time, and that's required many high capacity, high processing, and required a numbers of computer for performing the operation, for handling the user request. And these are very powerful in processing and power, memory, and storage, as they need to handle the concurrent request from multiple clients and manage large volume of data efficiently. That's why there should be very powerful in memory and storage capacity. In summary, the client machine serves as an interface for end user to interact with the database, while the server machine hosts the database management system and manage the underlying data storage and processing task. Host machine run the DBMS software and perform the underlying data storage and processing task. The communication between client and server allow user to access and manipulate the data storage in the database from remote location from any location. This client and server technique allow the user to access and manipulate the data. Manipulate means different querying data or update data. This is done by client server architecture. DBMS architecture. There are three type of architecture: single tier architecture, two tier architecture, three tier architecture. In the single tier architecture, all the components of the DBMS reside on single machine. But in two tier architecture, follow client server architecture, where the server provides the DBMS functionality that the client access using the API. The client use API, and with the help of API he sends the request to the server, and server will send the response according to the user request. And in the three tier architecture, it consists of application layer in addition to client and server to provide load balancing and enhance DBMS security. In that three tier architecture, we add this third a layer, that is a application layer, that handles the operations of that is in the middle of the user and the database. If the user sends any request, then it will go to the application server will manage the user request, and if its user request is valid, then it will proceed further and perform the operation in the database, and show the result to the user. And this is done by the application server. Tier 1 architecture. In the tier 1, the client server DBMS all present at the same machine. This architecture, when to use this architecture is suitable for small scale application, or for the situation where the simplicity is preferred over the scalability and security. Now, for a small scale application, we can use this tier 1 architecture, where all components are in the single machine. It's easy to set up and manage since all the components are single machine, but it may lack scalability and fault tolerance. This architecture has lack of the scalability. If you have a small organization and very limited number of people are using the database, then you can use this architecture, tier 1 architecture, where the all components are installed in single machine. Tier 2 architecture. When to use tier 2 architecture, the application is partitioned into two components. The client machine invoke the DBMS system functionality on the server and through the query language statement. The client machine will send the client machine invoke the DBMS system functionality on the server and send the query language statement for accessing the data. API stand like ODBC, Open Database Connectivity, and JDBC, Java Database Connectivity, are used to interact with the client and server. These are the APIs that interact with client, take the request from the client, and perform the fetch the data or perform the operation on the database. These API. This architecture is separate the client interface from the database backend. This architecture separate the client. There is one side of client, another side is the server, allowing more flexibility and scalability. And why it's providing more flexibility and scalability? Because client is separate, and if and the different operation at the client side managed by the client server. and it can be scaled, or it can be increased. The client server can be increased, and the server could also be increased. If you want to add more server and load, want to balance the load of the server, if the number of users are increasing, then you can increase the scalability of server. You can add more server and balance the load. uh, this is the tier 2 architecture. Tier 3 architecture, when to use tier 3 architecture, the application is partitioned into three logical component. In the tier 3 architecture, the application is partitioned into three logical component. The client machine serves as a front end and doesn't contain any direct DB call. This client machine directly will not access the database. First, the client machine communicate with application server. First, the client will communicate with application server, and which in turn communicate with DB system to access the database. This application server will access the database. Business logic as what action to take under the certain condition reside in application server. uh, when user is want to access some sensitive information from the database, then first application server will check it should give the access to the particular user or not. And this application server will handle all these business logics, and according to the user's access and authorization, he will send the query to the database. If user is not authorized to the access the any sensitive data, then he will discard and send you are not authorized for the accessing this data. Tier 3 architectures are particularly well suited for the web applications, where the scalability, data integrity, and security are critical. Tier 3 for the large organization, for the like WW World Wide Web application. Advantages. Advantages include scalability due to the distributed application server, because there are many servers running at a time, and they provide the service. And we can add more server, and balance we can balance the load of the server. Improve data integrity by minimizing the direct client DB interaction. Improve data integrity because direct client is not directly interacting with the database. First, he interacting with the application program, and we can define application server, and we can provide different constraints on application server, the so that the application server will manage the user's request query. Then first he will check the user request, then perform the operation on the database. Enhance the security, since client cannot directly access the database. This architecture provides the security because the client is not directly cannot directly access the database. There are some application server that there are some software running on the application server. That software will check the user request, then uh, access the database. Each architecture has its own strength and weakness, and choice depend upon the factors such as scale of application, performance requirement, security consideration, and development preference. You can see this two-tier architecture and three-tier architecture. In the two-tier architecture, user you, use some application, and this application directly access the database. But in the three-tier architecture, user like me, that uses some application client then uses some app and send a request to the application server, then application server will access the database. Thank you. That's all about this lecture.